Hello, everybody. Welcome back to another video. This video, we're doing something a bit different. I'm going to be teaching you how to conduct a particular statistical test called the Anova test, which is very useful for all of you who probably are taking biology and or even ESS and many other subjects where this test can come useful. It's a statistical test. So when you collect your data for your IAs or extended essays and you want to analyze it in your analysis section, this is where you conduct that test. And the analysis is a big chunk of marks in both the IA and the extended essay. So you want to make sure you don't skip on that. And that's why conducting the right statistical test is very, very important. Now, in my school, my teacher told me that the ANOVA test tends to score higher marks than the t-test, which is another very common test. But at the end of the day, it all depends on what kind of data you have and what you prefer to do. But the ANOVA test is a great test. It's very simple. You can calculate it, or you can conduct this test just using Excel. And you need something called the data analysis tool for that. Now, if you don't have this, you need to go on Google and search up how to install it. It's very simple, it doesn't take too long. It takes about 2 minutes. And then you will be able to do this test. So what exactly is the ANOVA test? Why do we conduct statistical tests in the first place? Now, once you have gathered all the data from your experiment, as you can see I have done over here, I have gathered, this is for my extended essay. This is just one part of the data that I had gathered. So in my extended essay, I was investigating the impact of the concentration of salt in the soil on the shoot length of different crops, because obviously crops are very important to all of us. That's where our food comes from. So I wanted to see how increasing salt concentrations in the soil, which is a global problem, the rise in soil salinity. So how is that going to impact the future of our food and the length and the growth of our plants? Because if plants don't grow, we're not going to have food. So that was my global issue and my topic. And I grew plants which I could find indoors in my home. And I did the whole works. I gathered data. As you can see, I had 10 different trials and I had different concentrations of salt. So the first is obviously no concentration. There was no salt in the soil. And then in the next, there was 0.05, 0.1, 0.15, 0.20, and 0.25. And this was all in moles per decimeter cube. And if you're wondering how I did this, basically, I changed the concentration of salt in the water that I was giving the plants. So I used to give water to them every day, and each one of these different sets of plants received water with different concentrations of salt. As you can see, these are the concentrations that the water had. So for example, one group of plants will receive pure water, which has no salt in it or no added salt in it. The next group of plants will receive water which has 0.05 concentration, mole per dm concentration of salt, so on and so forth. You get the idea. And each batch of plants, I conducted 10 trials. So basically, I had 10 different plants growing, and I measured the shoot length of each of them in each of these different trials. So it was a long, very long experiment. It took me about a month and a half to complete. But at the end of it was worth it. Very interesting experiment. But what is the purpose of this test now? Now, as you can see, I have gathered a lot of data, right? And as you can see that even within the same concentration of salt, the data isn't the same, right? Because one plant grew up to 30, another plant grew up to 27, another plant grew up to 27, 30, 28, it varies. So now if I want to understand what the impact of the salt concentration is on the growth of the plants, I have to get an overall picture, right? I have to see how it impacts it. And does having a higher concentration of salt impact the length of the shoot of the particular plant? In this case, it was the chickpea plant. This is the scientific name of the chickpea plant. And one way you could do that to see the impact, the overall impact, is to calculate the average of each group. So you could calculate the average of the group which got water with no salt in it. So that would be group number 1, which is 0.0. and you could calculate the average of all 10 trials, and here you get your answer. And you can do the same for the rest. And as you can see, there is a very clear trend, right? The average of the group with no salt is the highest, and the average of the group with the highest concentration of salt is the lowest, as expected. And based on this, you can say that, yeah, well, increasing concentration of salt does have a negative effect on the shoot length of the plant growth, but that is not enough. In science, we have to go further than that. Calculating averages is one form of analysis, but it's very surface level analysis. You need to go in deeper, because these differences that we see in the averages, they could be a result of random error, right? It could be random. Like in science, so many things are random. And this difference that we are seeing between them could be another random result. So we need to make sure that it is not random and that there is an actual relationship between my independent variable, which is the concentration of salt, and the dependent variable, which is my length. So independent is what I'm manipulating. In this case, I'm manipulating the concentration of the salt in the water I give them. And the dependent is what gets affected by the independent, which is the length of the shoot, if that makes sense. So I want to see what the relationship between these two are. And if the relationship between them is a cause and effect relationship, does changing one affect the other? And I can do that by conducting the Anova. The Anova tells us if there is a true scientific effect of changing the concentration of salt on the shoot length. That's why the Anova is important. And like I mentioned, why these averages are not enough to sufficiently conclude that there is an effect on the shoot length based on by changing the concentration of salt, is because these averages can be a result of random error, right? Or just luck. There are so many confounding factors when when doing scientific investigations. We need to make sure that we do a statistical test which gives us a solid relationship between the independent and dependent variable. And that's what the Anova test does. Now I'm going to show you how to conduct it. What you need to do, like I mentioned before, is first you have to click on the data analysis tool. Now, after you click it, a small dialog box opens over here. I don't know if you can see it or not. If you can't see it, I will post a photo of how it looks like along with this video. But if you can, then that's good. So there's a small dialog box that opens over here that gives us the option to conduct a variety of different analysis of different data. So what I'm going to do is I'm going to select the first one, which is Anova single factor. We have to do an Anova single factor test. So once you select that and click OK, it gives you something called an input range. Now, input range is basically the data that you want to analyze. And in my case, the data I want to analyze is, well, over here. All these trials, I have to select all of them, right? That's what I want to analyze. Okay, so I'm going to select all of this data until trial 10. You don't select the averages. Don't select the averages and don't select the independent, just the data. So all the trials, select the data. And they are asking us next if the data is grouped by columns or rows. So that basically means how is the data arranged in terms of an independent variable. So in mine, it is arranged in rows because row 1 is one independent variable, row 2 is the next independent variable. So I'm going to select rows. And the next we get an option. Are there labels in the first column? No, I have discarded the labels. The labels is basically the independent variable numbers that I have not selected. So I can ignore that. And the alpha is your degree of error. And so for the alpha, we always leave it at 0.05. That is the standard thing that we have agreed upon as scientists, and that's what we use in the IB as well. So you can leave the alpha at 0.05. Then you have to go to output options. Output options is basically where they will paste the results of the test, and you can do it on the same sheet or a new sheet. I'm going to choose to do it on the same sheet, so I can put output range. I can just go and select a random cell and it will paste the data result there and just click enter. And there we go. We have got our results. Now we have got this whole barrage of different numbers over here. And really all you need to look at for the ANOVA is two numbers. You have to look at the DF and you have, sorry, my apologies. You have to look at the F value and you have to look at the F crit value. Now, it's very simple. If you have to accept your hypothesis, so accepting your hypothesis means that what you said actually happens. That means that there is an actual relationship between the concentration of NaCl and the shoot length, or there's an actual relationship between your independent and dependent variable. If you want to confirm that, your F value must be larger than your F crit value. However, if your F value is smaller than your F crit value, that means that you have to reject your experimental hypothesis and you have to accept the null hypothesis. The null hypothesis states that there is no relationship between the independent and dependent variable. And conversely, the experimental hypothesis states that there is a relationship between the independent and dependent variable. In this case, you can see that our F value is much larger than our F crit value. And that would mean that there is a strong relationship between the independent and dependent variable based on our data. And that is it for the ANOVA test. That is all we do. Really, the ANOVA test, in essence, why we conduct it is to make sure that there is a true, reliable scientific relationship between our independent and dependent variable. And we do this so that we can either accept or reject the null hypothesis. And I've explained what I mean by that. If you accept the null hypothesis, that means that there is no relationship between the independent and dependent variable. However, if you reject the null hypothesis, that means that there is a relationship between the independent and dependent variable. Now, if you want to see how I have gone about conducting this statistical analysis in an IA or my extended essay, I have uploaded those on my Google Drive. And if you want access to it, just DM me and I will send you a link, a Google Drive link to it where you can access those. So that is it for this video. Thank you so much for watching. I hope I have helped you with this tutorial of how to conduct the ANOVA test. Again, if you couldn't see the dialog box earlier, which I spoke about, I will put a picture of how it looks and then you can cross-reference that with what I'm talking about, and hopefully that will help you out. Thank you so much for watching. I'll see you in another video with another question or a topic, depends. Take care of yourselves. And if you have any other questions regarding the ANOVA test or any other concept, please feel free to message me on my social media, send it to me by email or put it in the comments and I'll be more than happy to help you. Take care of yourselves and goodbye.